Okay, this is an optional lecture that's just meant to give you some extra examples at solving systems and determining the rank of a matrix. I suggest that you pause the video as you go along, trying to stay one step ahead of me in each of these examples, and this will give you an idea of exactly what type of operations or mistakes are holding you up. So we'll start with this one system of equations, which you've already written as an augmented matrix. The first thing we want to do is identify the pivot that we're going to work with. And we're always going to start in the top left corner. And here that entry is non-zero, so that will be our pivot. And we want to work to eliminate or turn to zero all the entries below that. So our first step would work on this 2 here. And what we'd want to do is replace row 2 with row 2 minus 2 times row 1. So that would give us 2 minus 2, 4 minus 4, 0 plus 8, 0 plus 8, and 2 minus 10. And so this is the resulting matrix, which has just been rewritten below. So next, we want to move down to the next row and try to eliminate this 2 here. And to do that, we would take row 3 and subtract 2 times row 1. Again, we're always using this pivot row to eliminate the entries below it. So then we have 2 minus 2, 3 minus 4, 2 plus 8, 1 plus 8, and 5 minus 10. Okay, so rewriting this matrix. Next step, again, moving down, we want to eliminate this 1. So here, all we have to do is add row 4 and row 1 and replace row 4 with that. And so that's pretty simple. We have 0, 1 plus 2 is 3, 3 minus 4, minus 1, and 6 minus 4, and 5 plus 5. Again, the same matrix is written below. Okay, so we're done with this first column. We've used that first pivot to its highest potential. So the next place we're looking for a pivot is generally in the next row, next column. And here we see that entry is a 0. And a pivot can never be a 0. So what we have to do is swap a row so that we have a non-zero number in our next pivot position. And here that's possible. We can use either row 3 or row 4. I think I use row 3 here just because it's a 1, and that 1s tend to be easier to work with, even if they're negative. So swapping that rows gives us this matrix, which we'll write again on the next page. Okay, so now I want to use this new pivot element that I just created to eliminate all the entries below it. One entry is already a 0, so no worries there. And now we just need to eliminate this 3. So to do that, I'm going to add this row to 3 times row 2. So row 4 plus 3 row 2. So that'd be 3 minus 3, 1, or minus 1 plus 30, 2 plus 27, and then 10 minus 15. And you can see the results here. And now finally, I'm done with this pivot column, so I'm going to move on to the next row, next column, and see if I have a pivot there. And here I do. 8 is a valid pivot. And you can already notice here that this small collection of equations, these bottom 2 equations, already aren't looking so good, because if x times some number, if say x times y, if 8 times x plus 8 times y is equal to negative 8, well, then we expect that 29 times x plus 29 times y should be equal to negative 29, which this is not. But we can see this kind of contradiction by proceeding through with our analysis. So the first thing I'm going to do, just to make things easier, is multiply this third row by 1/8, so I can turn this pivot into a 1, because that'll make it easier to eliminate the number below it. So in doing so, I turn those 8s into 1, 1, and minus 1. Rewriting this matrix here, Now I can use this pivot element to eliminate the 29 below it. And I would do that by subtracting 29 times row 3. So row 4 minus 29 times row 3. And so that'll give me 0, 0, and then a 24 here. And so here we see exactly the characteristic of an inconsistent system. We have all 0 coefficients, and we have a non-zero right-hand side of the equation. Now I could also talk about the rank of this matrix. All I do is count the number of pivots that were used, and I can see that the rank of the coefficient matrix is 3. It's not full rank. In order to be full rank, the rank has to be equal to the minimum of the row or the columns. I think we'll get into that in more detail in the next lecture. Okay, so let's look at another example. Here we're going to go through a little bit faster. First we identify the pivot, and then we want to eliminate the entries below it. So the first thing we'd do is eliminate the 2, and to do that we would subtract 2 times row 1. 2 times row 1. And at the same time, really, when we write this result, we can also think about eliminating this negative 1 here. To eliminate the negative 1, I'd want to add row 1. And so normally, we'd just write this down and we'd start to write the result, but this first row operation here, row 2 minus 2 row 1, would have us changing this second row. And the third row wouldn't change when we did that, so might as well just stop there and go ahead and do the third row operation, which is to add row 3 and row 1. So that's what has been done here. Okay, and this is just that same matrix rewritten. And what you'll notice is when we move on to find our next pivot position, it's a 0. And there's no row that I can swap it with to give me a non-zero pivot position. So in that case, I move on to the next column, trying to find a pivot position. And here that number is 1, so that'll become our new pivot. And our job will be to eliminate the numbers below it. So to do that here, just going to take row 3 and add 2 times row 2. And you'll see here that actually zeroes out this entire bottom equation for us. And so this is not a problem with inconsistency. I have my equation says 0 equals 0. But I clearly don't have a unique solution like I did in those other cases where we were solving from a triangular form. But let's proceed with the complete row reduced echelon form, reduced row echelon form. Even I get confused by those two things. And use our final pivot to eliminate the numbers above it. So to eliminate this minus 1 here, here it is rewritten. All I want to do is add row 2 to row 1 and replace row 1 with that result. So the first two numbers don't change. Again, I was zeroing out this column. I have 2 plus minus 1 is 1, and 1 plus 1 is 2. So this is reduced row echelon form. And the characteristics of that are always going to be that there are zeros to the left, the bottom, and the top of each pivot element. There are only 2 pivots here, and therefore the rank of this coefficient matrix is 2. And to write out our solution, we have to use the free variables. So again, the rank of our matrix is 2 because we have 2 pivots. Everything that's not a pivot column is a free variable. So here, x2 and x4. And we can convert this augmented matrix back to a system of equations. So I have x1 minus x2, 0, x3, plus x4 equals 2. And that's where I get my first equation here. And then x3 minus x4 is equal to 1. And so what I want to do is write my pivot column variables, again, those are x1 and x3, in terms of my free variables, x2 and x4. So I'm going to write x1 and x3 in terms of x2 and x4. I'm just solving for x1 and x3 in these two equations. And using that, it's rewritten here. Because these x2 and x4 are free, we're just going to set them to some arbitrary number. We're going to say x2 is equal to s, and x4 is equal to t. Well, then our solution is we just write down our vector of variables that we're looking for. x2 is s, x4 is t. And then x1 is s minus t plus 2. And x3 is t plus 1. So just fill those in vector format. Now, technically, this is a decent place to stop. This solution, no one can argue the correctness of this solution. But we generally like to break it down into its parts. And so we do that by writing it as a linear combination of s, a t, and something of an intercept or constant term. So to get this result vector, I have s times 1, 1, 0, 0. And so that's just the coefficient of s in every one of these terms, 1, 1, 0, 0. And then t is negative 1, 0, 1, 1. And then my constant term would be 2, 0, 1, 0. So I hope these two examples were helpful. If you have any further questions on this subject or you're getting stuck in any particular place, please feel free to contact me and we'll try to square you away.